Hello everyone, and welcome to the second edition of our De-Stressing Calculus. If you watched the first part, that was just Introduction to Limits. If you haven't watched it, check it out. It's worth watching, especially if you're having problems with limits. In today's episode, sorry for the shuffling papers. Today we're going to look at this really important proof, which is the limit of sine h over h as h approaches 0 equals 1. That's very useful because as you're trying to solve more limits, especially with the trig ones, just be able to work that out. That gives you a 1. That's really convenient, so that you don't have to prove this over and over again. You need to know that. So I'm just going to set up these three pictures. First is a triangle, AOB, in the unit circle, and this is the triangle right here. So then we've got the coordinates. This is 0, 0, this is 1, 0, and this is cos h comma sine h. Because it's the unit circle, so those are the points. And this is h, which is the angle. These are all the same thing, except this, instead of having that little triangle, it's just the whole sector. And this is actually its own triangle, which goes beyond the unit circle. And this point I'm going to call C, and that is 1 comma tangent h. If you don't know why it's tangent h is the height, try and figure it out. I'm going to let you figure this one out on your own, so that you can get the satisfaction of, learning something yourself. You feel smart. Not that you aren't smart. I'm sure you're very smart. But, if you can't figure it out, just look it up on the internet. I'm sure it's out there. Maybe I'll post it in the comment section. Probably not, though, because then all you slackers will just scroll down instead of figuring it out yourself. So now, the area of triangle AOB is 1/2 base times height. So it's just 1/2 times 1 times sine h, or 1/2 sine h. So next there's a sector, and the sector area formula is 1/2 radius squared times theta. So we've got 1/2 times 1 squared times h, so we just get 1/2 h. And the area of this triangle, COB, is 1/2 base times height, so 1/2 times 1 times tangent h, or just 1/2 tangent h. Now, we know that this little area here is less than this one, because this is essentially this with that little sliver added in, and this is bigger than this one because this is just this with that little area there added in. So we can say that 1/2 sine h is less than 1/2 h, which is less than 1/2 tangent h, and it's just greater than 0 because you can't have a negative area. It's not really important, but it's just worth noting. Yeah, it's just saying that the areas have to be greater than 0. Now we're just going to multiply by 2 over sine h, and then you get 1 because 2 crosses out with that, and the 1 over sine h crosses out with that. So we just get 1, which is less than h over sine h. Note that is very similar to what we're working towards, which is that. Sine h over h over sine h. And h over sine h is less than 1 over cos h. Now where do you get that from? Well, the 2's, they cancel out with that. And then tangent h over sine h. Well, tangent h is just sine h over cos h. Then multiply that by 1 over sine h. Well, that just gives you cos h because the sine h is crossed out. So, yes. Now we're just going to, there's a thing saying that the reciprocals, if you get the reciprocals of those, then you flip the operators. So I just kind of shifted them around. So like I could have it, 1 is greater than sine h over h, which is greater than cos h, but I think it's easier to do it with the less than symbols, because it just makes more sense. Go that way, a little small. If you don't like it this way, do it the other way. I don't care. But you get cos h is less than sine h over h, which is less than 1. But we know that the limit as h approaches 0 of cos h equals 1, because in the first section, the first part of this 3-part series, we saw that you can just plug in the number, as long as it doesn't give you the denominator, plug in 0, well you get cos of 0, which is 1, that's 1. And you also know that the limit of 1 as h approaches 0 is just 1 because it's just a flat line, which is bad if you're in a hospital. You don't want to see that in a hospital, just saying. If you're in a hospital right now, I'm sorry for that joke. I made it at your expense. So since you know that that is 1 and that is 1, then by the pinching or squeezing or sandwich theorem, it all depends on which textbook you're using. They all mean the same thing. That means that limit of sine h over h as h approaches 0 is 1. simply because this theorem right here, if you don't know what that is, essentially if 1 is greater than that number, and that greater is greater than 1, then by default, since there are no limits, then this must equal those. So that's how you figure that out. And that is really useful. You're going to use that a lot. So there we go. That was part 2 of our de-stressing calculus series. Come back for part 3, in which we will discuss... Actually, I'm not going to show you the proof. I'm going to make you watch the next video. And it is the limit of 1 minus cos h over h as h approaches 0. That is a good proof to know as well. See you next time.